Hello, and welcome to the second actor tutorial for the 2D action platformer kit. In the previous tutorial, we delved into playable actors. This time, we're focusing on non-playable actors, or enemies, that leverage the same actor system but incorporate AI to form modular behavior patterns. Let's begin with an example, the bouncing enemy. If we examine its prefab, you'll notice the structure closely resembles that of a playable character. It has an overarching parent object and, as a child, an actor object. Unlike playable characters, enemies don't require a UI object, but instead they feature a behaviors object. Focusing on the parent object, it contains the AI patrolling system script. This script is crucial as it orchestrates the enemy's behavior by referencing various potential behaviors. Our bouncing enemy, for instance, primarily exhibits bouncing behavior, so it doesn't necessitate attack behavior. However, it does need a link to the script that governs its bouncing patrol behavior, which you can find in the patrol behavior field, pointing to the corresponding script within the behaviors game object. As enemies in the kit are also state machines, they come with a collection of states. In the case of this bouncing enemy, the jump state is primarily utilized. To visually communicate this behavior, a set of animations is essential. By expanding the actor object and exploring the character object, we can inspect the animations assigned to this enemy, including die, freeze, idle, jump, and take damage. Similar to the player actor, enemy actors use a base animator configured with a set of predefined animations. Now, let's see this enemy in action. We'll revisit stage 1 and drag the bouncing enemy into the scene from the prefabs enemy folder. We'll position it near the player's starting location for immediate interaction. Upon hitting play, you'll see the enemy actively bouncing, ready to engage with the player. Observing the bouncing enemy's state machine, we notice it alternates between the jump and fall states due to its patrolling system. This cyclical behavior is crucial for maintaining the enemy's dynamic movement pattern. Scrolling further down in the inspector, we encounter a new component that equips the enemy with the capability to inflict damage on the player upon collision. Regarding the enemy's stats, let's revisit the actor script. Here, the bouncing enemy actor data is referenced. This scriptable object is the same type used for managing player stats. It allows us to set parameters like health, movement, and jump data for the enemy. Since the example enemy has only one health point, it can be destroyed with a single hit, triggering its transition to the die state and subsequent destruction. Now, let's experiment with modifying this enemy to gain deeper insights into how enemy behaviors function. We'll start by unpacking this enemy prefab to avoid affecting other instances. I want to add a shooting behavior, so we'll create a new game object under the behaviors object and name it shoot behavior. In the inspector, we add the AI behavior shoot player script. Next, we need a player detector. We'll add a new game object as a child of shoot behavior and call it player detector, equipping it with a player detector script, which we then link to the shoot behavior script. I'll also remove the delay so the enemy shoots immediately upon detection. Adjusting the player detector involves setting an origin point, in this case, the enemy actor. A green box representing the detector's dimensions appears around the enemy. We'll reduce the gizmo's opacity to 0.5 for better visibility and adjust the detector size to our preference. After removing the detection delay and selecting the player layer, our detector is ready and it will now accurately identify the player. Finally, to enable the enemy to shoot, we must incorporate this new behavior into the patrolling system and provide it with a weapon. To arm our enemy with a weapon, we'll add a new component called GiveActorWeapon. Within this component, we select the weapon data to be used by the enemy. For our purposes, let's equip it with the turret enemy weapon. Next, we need to enable the actor's weapon system to actually trigger the shooting mechanism. This involves adjusting the weapon object of the character. Typically, this object contains an animator component, but since our enemy initially lacked a weapon, the controller field hasn't been set. To rectify this, we navigate to the enemy's animations folder. Here, we'll set up a new animator override controller. Let's create a new folder, perhaps named weapon, and within it, right-click to create the new override controller, naming it Weapon Animator. Following this, we create a new animation, possibly named Shoot Animation. After setting up these components, we can set the base animations as the controller for the weapon animator and assign the newly created shoot animation to the shoot slot in the weapon animator. Returning to the character's weapon object, we drag the weapon animator into the controller field, thus enabling the weapon to access weapon animations. Now let's open the Animations tab and select the Shoot animation. Since our bouncing enemy doesn't visibly wield a weapon, we won't need a custom animation for it. However, we must inform the attack state about the timing of the shot fired by the enemy. We achieve this by adding an animation event to the shoot animation and selecting Invoke Animation Action as the function. This action prompts the attack state to execute the code necessary for firing the projectile. With these modifications complete, our enemy is now equipped with a new shooting behavior. To see it in action, we hit play and observe our newly enhanced enemy. We can see that upon detecting the player, the enemy successfully performs the shooting attack. However, we notice an issue. The projectile isn't heading in the correct direction. This misdirection occurs because the actor's projectile spawner isn't flipping with the actor. To correct this, we can utilize the Unity events in the actor renderer script. Let's exit play mode and select the character object of the actor. In the actor renderer script, we'll add an event to onFaceRight. Here, drag the projectile spawner into this field and choose projectile spawner, face projectile spawner right as the function. We'll repeat the same process for the onFaceLeft event and choose the projectile spawner, face projectile spawner left function. Now, let's test it again. We can observe that the enemy now fires projectiles in the correct direction, aligning with its orientation. This example demonstrates the ease and flexibility of creating custom enemy behavior by mixing and matching different AI behaviors. Furthermore, you can arm enemies with any weapon, even those used by the player character. For instance, if we equip the enemy with the freeze weapon, it gains the capability to freeze the player, showcasing the versatility and consistency of this actor setup. It allows both playable and non-playable characters to interact and behave similarly while remaining efficient and straightforward to customize. And this wraps up our tutorial on the enemy actor for the 2D action platformer kit. If you have any questions or need clarification, please drop a message here or join our discussion on the official Discord server linked in the video description. Thank you for watching, and if you wish to stay informed about updates to the kit or upcoming projects, please consider subscribing.